Hi everybody and welcome back. We continue today with lesson 103 and I'm going to date this the 11th, 5/11/2020. So here goes. The do now is just a quick review question from what we learned about yesterday or in the last lesson. So we're going to just quickly run through that. They want us to identify the center and the length and write the equation. Well, that's convenient because those are the two things you need to write the equation of a circle. So the center of the circle is over here. This is over 3 up 2, making my center at 3, 2. And my radius, this isn't drawn perfectly, but it is supposed to be hitting right here. We could see right here. So my radius on this circle would be 3. And then to write the equation, that would be x minus 3, the whole quantity squared, plus y minus 2, that whole quantity squared, equals radius squared, so 3 squared is 9. And that's the 3 parts of the do now. Okay, so reminder. In the last lesson, we talked about the center radius form for the equation of a circle. And this equation holds true whenever the center is at h, k, and the radius is of length r. And we looked at this in lesson 101. X minus h squared plus y minus k squared equals radius squared. I have one more practice problem for you with this, and then we are going to talk about another way to write the equation of a circle. So, looking at this one here, we can clearly see that the center of our circle in example 1 is at -5, 3. They even have it labeled for us. But we cannot nicely count out where the radius is taking us to because this circle is sitting clearly between 2 boxes. But what they did do is they gave us another point on the circle. So what you have to realize is that that means I can figure out how long the radius is using that point. Now there are 2 ways to do this at this point. We can use these 2 points and just go over to distance formula and figure it out that way. Or quite honestly, what I think is probably the easiest, which is to draw one horizontal line, draw one vertical line, turn this into a right triangle, and then you can just count boxes and use Pythagorean theorem. So down here on the bottom, I have 1, 2, 3, 4. And going up the side, 1, 2, 3, 4 boxes. And I'm trying to figure out what the radius is, which is the hypotenuse of that right triangle. So I can use a squared plus b squared equals c squared. Using Pythagorean theorem here lets me avoid having to plug into that big formula. If you don't mind the big formula, go ahead, you can use it. This will be 16 plus 16, which is 32. And then my radius would be the square root of 32. Now, my end goal here is to write the equation of the circle. When I plug into the equation of the circle, my radius is going to be squared. So that means there's no need for me to simplify the radius. I can leave it as a big radical that I know could be broken down, but I don't need to simplify that because taking that information and the fact that according to this graph, the center of the circle is at -5, 3, I can put these 2 things together into the equation of the circle. So that would be, of course, x minus -5 squared plus y minus 3 squared equals the square root of 32 squared. Now, neatening that up a bit, of course, we remember that minus a -5 means we could write that just as x plus 5 squared. Then we have y minus 3 squared. And squaring a square root, well, they cancel each other out. And that's just equal to 32. So that right there would be my equation of that circle. Okay, and then they're giving us one more example that's just like that. They're giving us a diameter, or they're telling us the diameter has certain endpoints, and we're supposed to write the equation of the circle. This one is a little bit more tedious. It's a little bit more algebra driven than the last one. First of all, I don't have a graph, so I'm not going to use Pythagorean theorem unless I go get graph paper and graph it first. So because of that, I'll use distance formula. But the other thing is, I don't have a center of this circle right now. I just have the endpoints of the diameter. So just from what I know about a circle, this is not a graph of this, it's just a general picture of a circle. if you have a diameter and you know the endpoints of that diameter, you can figure out the center by figuring out what the midpoint would be. So the first thing you would need here is the midpoint formula. We haven't used that in a little while. Remember, that's the one that's the average. So I would add x1 plus x2 and divide by 2, and then add y1 plus y2 and divide by 2. My midpoint is going to be what I get now if I plug in these numbers. So this will be 4 plus negative 6 divided by 2, and negative 1 and 7, negative 1 plus 7 divided by 2. Following that work through, I end up with negative 2 divided by 2, and I end up with 6 divided by 2. And then finally, I can finish that up with negative 1 comma 3. So what I just did here was I found the midpoint. What is the midpoint in this situation? The midpoint is the center of that circle. So now I have a center to work with. Sorry, went off the page. There you go. Now, in order to write the equation of a circle, remember, you don't only need the center, you also need the radius. So what I can do is I can take this center, and I can take either one of these points that I started with, and I can find that length, because that would be the length of the radius from a center to a point on the edge of the circle. So I am going to choose to use my center, negative 1, 3, and I'm going to choose the first point here just because I feel like it. The numbers are a little smaller, 4 comma negative 1. And I'm going to go over to my distance formula. Distance formula here. X2 minus x1 squared plus y2 minus y1 squared, all underneath the great big square root sign. So that becomes the square root of, and this would be 4 minus negative 1 squared plus negative 1 minus 3 squared. Just being very careful with my arithmetic here. This would be 5 squared plus, this would be negative 4 squared, which means it will be the square root of 25 and 16, which is the square root of 41. So I now have I have a radius, and I have a center. So with those two pieces of information, I can go to my equation of a circle. Remember, that is x minus h squared plus y minus k squared equals radius squared. That is going to be x minus negative 1 squared plus y minus 3 squared equals the square root of 41 squared. And when I simplify that, I will have x plus 1 squared plus y minus 3 squared equals 41. And that's my final answer. That's a long question. Chances are that on a Regents type exam would probably be something that would get some partial credit. For right now, what I want you to realize is that this is one of the topics from this year that carries over into Algebra 2. In Algebra 2, you still use the equation of a circle. You still have to know how to do this. So this is actually a very key part of some of the stuff that we're doing from home, because it does lead you right into things that you need for next year. All right, so the next thing that we have to do is we have to talk about a different way that we can write the equation of a circle. What we've done so far with center radius form is the most common way that we see the equation of a circle written, but it sometimes is also written in general form. And general form looks like this. It's the x squared term and the y squared term, then c times x plus d times y plus e equals 0, where e is your constant. Now, there are two things you need to be able to do. You need to be able to get from the form that you're used to into making it look like this. And then you need to be able to take it from when it looks like this and learn how to turn it so that it looks the other way. So the easier one is the one we're going to do first with example 3 here. We want to convert that thing into general form. To convert it into general form, what we need to do is we need to multiply the whole mess out. So when you see x minus 2 squared, that means x minus 2 times x minus 2. Using FOIL, or the boxes method if you prefer, you end up with x squared minus 2x plus 4, which means we have x squared minus 4x plus 4. That's the most we can do with that for now. We'll come back to it. Then we have to deal with what comes after the plus sign, which was y plus 5 squared. That means y plus 5 times itself, y plus 5. That means I now have y squared plus 5y plus 5y plus 25 for a grand total of y squared plus 10y plus 25. And then if I go back and look at the equation that was given to me in the first place, I have to remember that there was an equal to 9 on the other side. Now, in order to finish this problem, I have to start to rewrite it so that it will look like this general form up here. I can write the x squared term first, that's fine. I can write the y squared term next, so x squared plus y squared. Then I'm supposed to write the term with the x on it, so that would be minus 4x. Then I'm supposed to write the term with just a y on it, so that would be plus 10y. And then I can add together these two numbers right now. This will say plus 29 equals 0. But to have my full general form, I have to have this equation equal to 0, not equal to 9. So to finish this problem, I would just have to subtract a 9 from both sides. And this is x squared plus y squared minus 4x plus 10y plus 20 equals 0. And that mess, that's your answer. So we've converted it into general form. The nice thing about converting to general form is really just practicing your algebra from last year. That's really all you're doing there, is writing those out twice, doing your multiplication, and then combining like terms. Now, the slightly more complicated problem that you have to do here is going back in the other direction. If I start you with that general form, can you work backwards enough to make it look like the circle radius form that we used the other day? Well, you can, and this is why we spent lesson 102 going over how to complete the square, because we're going to use components from that idea in order to get this problem done. So for starters here, I have to group together the x's and the y's. So I have an x squared, which I'm going to write first, and I have a minus 4x, which I'm going to write next to that. Then separately, I have a plus y squared that's over here, and I have a minus 6y that comes after it. And then on the end of this, I have this plus 8 equals 0. Well, I'm trying to get this to center radius form, which means I want to move the 8 over to the other side. So I'm going to subtract an 8 from each side, and this will now say equals negative 8. So this is your first goal, is to put the x's first, the y's second, and make it equal to whatever number you have on the other side. Now comes the way that this connects to the completing the square that we went over in the last lesson. You have to look at the first two terms and complete that square. How do we complete a square? We look for our magic number. So this is negative 4. Negative 4 divided by 2 is 2. 2 squared is 4. To complete this square, I would have to add a 4 to it. Back to your old middle school rules about solving equations. If you add a 4 to one side of the equation, you have to add the 4 to the other side also. That makes this first part become x squared minus 4x plus 4. And if I factor that, that would be x minus 2 times x minus 2, which you can write as x minus 2 squared. See how that's shaping up to start to look like the other version of this equation? That's how we're going to get there. We have to do the same thing with the y's. So now with the y terms, I have a minus 6 in the middle. Half of that would be negative 3. Square that, I would get 9. So I need to add a 9 to that part of the problem so that I will get a perfect square. If I want to do that on the left side, that's fine, as long as I also do it on the right side. So let's deal with the y's first here. We have plus, and we have y squared minus 6y plus 9. This can be factored to y minus 3 times y minus 3. That can be rewritten as y minus 3 squared. All of that is equal to what we get over here on the other side, when we add this all up, -8 plus 4 and then plus 9, we should end up with a 5. And doesn't that look familiar now? That is center radius form. X minus 2 squared plus y minus 3 squared equals 5. This was the first thing they wanted us to find. We found it. The next thing they want us to do is state the center and the radius. So we get the center by switching these signs here. So my center here must be 2 comma 3. And my radius is what I get by taking the square root of this number over here on the other side. So my radius is the square root of 5. Good. So that's the whole problem. This is my center radius form, and these are my center and my radius. Now, the next problem is just like that. It's another problem to let you practice what we just did. So if you think you've got it, you may want to shut this off and try it yourself and then come back to check. If you'd rather work through it with me, we can do it together. Now this problem started a little nicer than the last one because the 41 was already on the other side. So I can begin here just by grouping together the x's and the y's. Well, look, they did that for me also. So now I can just worry about completing the squares. I have I'm going to move it over so I can have a little more room to work. X squared plus 4x, I'm going to need to complete that square. Plus, I have y squared minus 12y. I'm going to need to complete that square. And altogether, the whole mess is equal to 41. So, to complete the first square, half of 4 is 2, 2 squared is 4. I need to add a 4 on this side of the equation, so I better add a 4 on the other side with the 41. This comes out to be x squared plus 4x plus 4, and I'm not adding or subtracting here, I'm just making it look prettier. This becomes x plus 2 times x plus 2, and that I'm allowed to write as x plus 2 squared. Now I also have to do the same thing with the y terms. When I look at the y stuff, I have a negative 12 in front of the y. Half of that is negative 6 squared, 36. So I would need to add a 36 to both sides. When I do that on the left, my second set of terms here is now y squared minus 12y plus 36. Mess around with that for a minute and you realize that would factor to y minus 6 times y minus 6, which means I can write that as y minus 6 squared. And then over on the other side of the equation, what is that going to be equal to? Well, the 4 and the 36 that I added in, I also have to add to the 41. So my grand total here is equals 81. So this mess, this is center radius form. And then this problem specifically asked you what's the center and what's the radius. Well, the center is easy. We're just going to change our signs here. So our center is negative 2 comma positive 6. Our radius is the square root of the number on the other side, so the square root of 81 is 9. And those are your answers. So you now have, there we go. Didn't move that up enough for you at first. You now have the knowledge, you have the skills to turn back and forth between general form and center radius form. All right, there is one little extra part that goes on this lesson, and that is about the equation of a circle. Sometimes you'll have an equation that looks like it might be the equation of a circle, but you have to be a little extra careful in analyzing it to see whether or not it truly is. So sometimes when you look at an equation in center radius form, you are going to end up with something that really is a circle. Sometimes the equation sort of looks like it, but it's actually just a point. And sometimes it's an empty set. It's actually, there's kind of like an error in the problem and it doesn't make anything at all. So we are going to talk about these three options. When we look at an equation that is in general form, we should be able to tell which one of these it is going to be. If the right side of the equation is a positive number, if we can get it equal to a positive number, then we know that this thing is a circle. If the right side of the equation is a negative number, then we would say it's an empty set. It doesn't actually exist. It's not possible. And last but not least, if the right side of the equation works out to be 0, then it isn't actually a whole circle, it's just a point. The point that would be the center of the circle otherwise. So, when we look at a problem like this one, we can actually see I said this wrong. It's not general form. This should be center radius form. So you can make that little change. It'll make a little bit more sense. When we look at an equation that looks like this, and we can tell that from here we can clearly say that the center is -2, 0, and the radius is the square root of 4, which is 2. As long as we have a center and we have a radius, we know for certain that this equation is going to make us a circle. When we look at this problem here, it almost looks okay. My center, when I look at the left side of the equation, is -3, +2. But my radius would be the square root of -2. What? We can't find the square root of -2, at least not yet. You'll be able to next year. But right now, that's not part of our real numbers that we use in geometry. So there is no answer here. We can call this the empty set. We can say there's no answer. This is not possible. This is an empty set. And then last but not least, this last situation here. My center is clearly -5, +5, and my radius would be the square root of 0. Well, if something has a radius of 0, that means there's nothing but the point that you're starting from. So if you go to draw the center, and then you go to draw a radius of 0, you can't draw anything else. You're left with the point that is the center. So this is an example of equation that actually turns into a point. So there you go. That's today's lesson. That's 103. We have one more real lesson left, and then it's going to be a lot of review and different things. So the homework assignment is attached here as well. Good luck with that, and I'll be back again with another video soon. Bye-bye.